Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems from the question paper CSIR National Eligibility Test held on February 28, 2025. In this video, we discuss the solution of a problem from the section Ordinary Differential Equations, which is related to the change of independent variable of a given differential equation. This question is from the part C, which is a multiple select question. There can be more than one answer and the question carries 4.75 marks. The question ID is 704121. This question is suitable for all these examinations. Right. The given question is, suppose that the differential equation d square y by dx square plus p of x into dy by dx plus e to the power of 2x into y is equal to 0, where x belongs to the set of real numbers, transforms into a second order differential equation with constant coefficients under the change of independent variable given by s is equal to s of x, satisfying ds by dx when x is equal to 0 is 1, then which of the following statements is true? We are given four options. Option 1, e power minus x into in brackets p of x plus 1 is a constant function on R. Option 2, e to the power of minus 2x multiplied by p of x is constant function on R. Option 3, s of x is equal to e to the power of 2x by 2, where x belongs to R. Option 4, p of x tends to 1 as x tends to infinity. Let's now discuss the solution of the problem in detail. We have the given second order differential equation with variable coefficients. d square y by dx square plus p of x into dy by dx plus e to the power of 2x into y is equal to 0. Let's call this as the equation 1. We change the independent variable from x to s by the substitution s is equal to s of x. Then dy by dx is equal to dy by ds into ds by dx. We use the chain rule. And d square y by dx square is equal to d by dx of dy by ds multiplied by ds by dx. First function dy by ds and d by dx of ds by dx is d square s by dx square, ds by dx multiplied by d by dx of dy by ds. And d by dx of dy by ds is d by ds of dy by ds into ds by dx. Then it will be ds by dx into d square y by ds square. That is the second term. Right. Take these things and substitute in the given equation. Then it becomes in the place of d square y by dx square, write this. P of x into dy by dx is dy by ds into ds by dx plus e to the power of 2x into y is equal to 0. Right. Now, write this as d square y by ds square, this one, into ds by dx whole square, plus collect the terms containing dy by ds, that will be from the first one d square s by dx square plus p of x into ds by dx whole into dy by ds plus e to the power of 2x into y. Now divide throughout by ds by dx whole square. Then you will get this one. So e to the power of 2x by ds whole square, ds by dx whole square into y. That's the coefficient of y. And the coefficient of dy by ds is this one multiplied by ds by dx whole square. This is the second equation. This is the transformed equation. Now it is given that this transformed equation transforms into a differential equation with constant coefficients. That means this should be a constant, this should be a constant. Right. So that's what we got the second equation. Now it's given that the equation 1 transforms to a second order equation with constant coefficients. Therefore, the coefficient of y e to the power of 2x by dx whole square must be constant, and the coefficient of dy by ds must also be constant. First, take e to the power of 2x by dx whole square as constant is equal to, and then solving for ds by dx, that will be ds by dx is equal to some k times e to the power of x. Now, given the condition s is equal to s satisfies ds by dx when x is equal to 0 is 1. So, substitute x is equal to 0 on both sides. ds by dx at x is equal to 0 is 1, implies 1 is equal to k e to the power of 0. That is k is equal to 1. Thus, we get ds by dx is equal to e to the power of x. Integrating, we will get s of x is equal to integral e power x is e power x plus c, where c is the constant of integration. Right. Take this. Under this change of independent variable, this change, the given differential equation 1 transforms to d square y by ds square, to second equation, plus d square s by dx square. ds by dx is e power x. Second derivative is also e power x. So, into e power x plus p of x into ds by dx is e power x by ds by dx whole square, that is e power x whole square, into dy by ds plus e to the power of 2x by ds by dx whole square, that is e power x whole square, into y is equal to 0. Now, simplify d square y by ds square, and here e power x is common. So, e power x by e power 2x, that will be 1 by e power x, that is e power minus x into 1 plus p of x into dy by ds plus y. E power 2x by e power 2x is 1 y. So, this is the transformed equation, and this is given to be a equation with constant coefficients. The coefficient of y is already 1, so therefore this must be a constant. We continue in the next slide. Right. Now, since the equation 1 transforms to a second order differential equation with constant coefficients, this coefficient of dy by ds must be a constant, that is e power minus x into 1 plus px must be a constant. Let us look at the options. Option 1 says e power minus x into p of x in brackets plus 1 is constant function in on R. Therefore, option 1 is true. Let us look at option 2. E to the power of minus 2x into px, can it be a constant function? Suppose e power minus 2x into px is equal to k1, a constant. Then p of x will be equal to k1 times e to the power of 2x. Then e power minus x 1 plus px is a constant, that is equal to e power minus x into 1 plus p of x is k1 e to the power of 2x, which is not a constant, a contradiction. Therefore, option 2 is not true. And option 3 is obviously not true. Why? Because the change of independent variable by means of the substitution s is equal to s of x is e power x plus c. E power x plus c. It can't be e to the power of 2x by 2. Right. So that's the thing. And if you take s of x is equal to e to the power of 2x by 2, ds by dx is e power 2x, ds by dx when x is equal to 0 is 1. It satisfies the condition. But the coefficient of y after transformation is not going to be a constant. So therefore, option 3 is not true. Right. Can p of x tend to 1 as x tends to infinity? So we have e power minus x into 1 plus px is constant, let us say k2. From this, 1 plus px is equal to k2 into e to the power of x. Px will be equal to k2e into e to the power of x minus 1. Now, can this tend to 1 as x tends to infinity? No. So notice that p of x is not tending to 1 as x tends to infinity. Therefore, option 4 is not true. Summarizing all the options, the answer to this question is option 1. That is the detailed discussion of the solution of this problem. So, many a times students and teachers take the substitution as s is equal to s of x is equal to e power x, and then they do it and you will get it, because you have guessed rightly what is s is equal to s of x. You have guessed rightly, therefore you get it. But our question is, how did you guess? How did you guess that one? For that, systematically transform the equation and take the condition that it is transformed into a differential equation with constant coefficients. Then you get the substitution as s of x is e power x plus c. That is the logical way of getting it. Right. Anyway, I am sure that you have understood the solution of this problem. Thank you for watching this video now. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends. Please subscribe my channel if you have not already subscribed. Yes. I am sure that I am going to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.